All right. I was like, oh, am I gonna do this like uh with the mic off? Cause I'm watching Curb right now, bro. I'm vibing, and I'm like, you know what? We gotta finish this thing. So, guys, screw the dovetail. This is such a stupid design. I was trying to make the smallest, simplest thing, but it's like now it's time to. And we want to delete this part too. Wait, hold on. Wait. Let me think about this. I'll just copy the sketch geometry. We'll keep this as it is. Uh, do I want to do that because it's already in the assembly? No, I think I want to make it again. No, but then I have to put those holes there. How hard is that? Is that different sketches? See, I gotta be better because the thing is these holes are from a way earlier. Or what the hell? Oh, I did a mirror, bro. There is stuff about CAD that's just like, why am I doing this? But the thing is, then I gotta copy this part. Why don't I duplicate this and then roll it back? That seems like a good plan. So this is going to be, uh, oh, um, this is, um, so it's gonna be, yeah, Y, uh, Z holder. That's what we're gonna call it. All right, and then this is gonna go way over here. Okay, and then we're gonna just roll this back to right after these holes were done, I guess. Okay, and then we also want to just get rid of all of these features and this feature. So we just want to get rid of, I guess, this sketch. Wait, we want this. We want this, which is the same thing. I don't want this because I'm getting rid of that. I don't know what that is. Oh yeah. This extrude and this sketch. Yeah, I am deleting that. Okay. Oh shit! But what's wrong with this? Oh, because it's referencing weird stuff. Oh yeah. Um, because I forget where this was. What's happening? Should I just redo it? I'm gonna have to reprint it anyways. I might as well redo it. So we just delete that sketch too. So those holes and this extrusion, we'll just delete that. Okay, and then let's just get rid of this. I'm trying to think about though. So this is where we're at. It's just a cube, which is fine. What's up with that? Yeah, I don't even know what that sketch is. I think that's nothing. What is that? Oh, it was literally just to get that dimension. All right. Okay. So, all right. So let's just start with this. We want to go to this sketch. No. Why am I dumb? Well, it says extrude one, but it's not sketch one. Oh, that's ridiculous. All right. So then here, so what we want to do is we want to do like two. Uh, this and this are horizontal. What? Dude, bothers the hell out of me. And then you undo, and then it like doesn't work. Okay. Um. Okay. And then what's the dimension here? This is going to be 8.2. Oh, you know what I haven't checked though? I haven't checked if I have the springs I need. I wonder if I could do the math here. That would be kind of fun, right? Or at least tell GPT to do the math of like um the 995 servo against two springs. How high? I mean, can it lift it, I guess is the question. How deep did I make these? It's an arbitrary thing, but we'll 10. I don't know what am I doing? Um okay. Wait, is this fully defined? I can't even tell. See, that looks black to me, doesn't it? What the hell? I don't know. That's weird. I'm gonna refresh this. Why does it look? Dude, what? Is it night mode? Why does that look black? Or this one? Does it look like that in the stream? I'm guessing it does. Okay. Whatever. Let's just do this thing. What? Dude, it's so annoying that you can't, like, whatever. The thing is about Onshape is that, like, do I really want to do this every single time? Of, like, whatever. No, but I don't even want it on that part, do I? Because this was the result of a duplication. I don't care. I don't care. It's not that important. But we want to do this. This, extrude this by 10. Oh, remove. Okay. Okay, now we need to think about this next part. This next part is going to be if we look at the servo, we probably want it to we want the most amount of travel possible, but we can at least get a look at it's always good to look at this. I love that I can just pull this up. It's so sick. So it's 20. So why don't we build this in place? I don't know. This is the thing about assemblies versus. I honestly don't know what's better because I feel like I might be more productive if I just. But it's like then I want to use the actual thing. In any case, let's just make it like 40 tall. Because it's going to need 20 plus 10. So let's make it 30. Okay, so, but I do want to put a part on here. So first off, technically, this needs a set screw. Then it's like 10 mils away. So we actually want to make it 4 mils away. So make it 4 mils away, which is real close to the edge. I guess that's actually better because it gives us more space there. So we're going to take, this sketch. See, this is the thing, man. This sketch. I'm just being a bad, dumb designer. Okay, so this distance is now going to be 4. Oh, no. Sorry, delete that. Undo, delete. This is going to be 4. Oh, okay. Easy peasy. So now we're gonna sketch on here, and okay. So one variable that I need. See, actually, this is what I'm saying is like, should I just make a document called variable studio that just houses? All right, let's try it. We might as well try to be, innovative at all. So this is just going to be like params. It's just called params. It's just a document, and all it has in it is one. Go away. One variable studio. Okay, and so this is going to be tap hole reduction. Tap hole reduction, and it's 0.4 millimeters. And basically, it's when implementing a hole to be tapped into PLA, reduce the intended diam by this amount, i.e. M5, or for M5 hole, diam is equal to 5 minus tap hole reduction. Just like, I don't know. Okay. And this is insert hole reduction, and it's 0.3. But actually, but then it would be cool if you could write a program where you're like, it would be cool to have a program that easily defines configurations. And yeah, it's basically like, I guess it's a configuration, but it's like you take the entire part, and the part uses a variable or a parameter like in a bunch of places, and it's basically a functor. Not to be like gay, but it's like a functor. Um, so I did it, right? So now I can just do, so let's just do this. I don't think we have a sketch on here. And I guess, no, but use is convenient. Oh, but it doesn't give me the center. Or, okay, whatever. So let's just do boom, 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 boom. And then it's like, it's going to be, see, what I want to say right here, that would be so cool to write in code, is just, I don't know, M5 hole, 10 away, and then, I guess it's not, yeah. Did I do this already? I guess we need this, and it's 10 deep, so we might as well make it, I don't know, do you want it as deep? I'm just gonna do 5. Wait, no, but not 5 from there. Hold on, this is going to be, oh, and see, but that's the thing, is like, okay, wait, hold on, let's try to implement this whole thing. So like, M5 hole, wait, but hold on. Oh no, but in this case, it's quite literally 5. No, oh, well, I got one a few days ago. I look like my name is Edgar, bro. See, but do I even need this? Because M5 hole, well, we could just put this here, but this isn't really what I want, because it's actually quite literally, wait, but okay, wait, so we did this. So now we want to insert this variable studio. I forget how this works, but I think that this is the scoping. If I do insert variable studio, other documents, owned by me, params, create a version in params. Okay. All right, great. So we have this, and it's named. Okay, but see, okay, but this is gonna be a conflict. But we're not gonna be able to delete it. So that's kind of the painful part is that it doesn't let you delete this. It would be copy table. Yeah, that doesn't do anything. But let's start to use this. So in our case, where the heck are we? We're building Z holder. This thing is only 10 deep, so that means that the center of this hole needs to be. So it's gonna be 5 minus tapped. What? Tap hole reduction. Okay. But that's the worst. So what we just want to do is we just want to make a parameter called M5, and that's just gonna be 5. It's literally that's like the goofiest strat ever. It's only because 5 you got to type millimeters, so it's. But the annoying thing though is that I guess it's not the optimal thing because if I delete this and I try to give this dimension. Oh no, I don't know what I'm talking about. M5 minus. It's only so that the millimeters, but it does save me a character, and this is gonna be tap hole reduction. And why is that wrong? What? I don't. Wait, what? Oh, did I not even do it? Oh, wait, what? Wait, but M. Oh my God! Is it because you have to make a version? Bro, no, no way. Or is it that it doesn't propagate? If we go to this documents, wait, why can't I scroll down? What the hell? What is going on? No, but wait. Oh, that's so annoying. So you can't even do that. That's kind of ridiculous. I don't even understand why they don't have a solution to that. Kind of a goofy workflow, but all right, let's just do this. I don't even care. Let's just do this. Okay, so edit this sketch. This is going to be nothing. Just make this 5. And then this is going to be 5 millimeters minus tap hole reduction. Okay, then the distance from here is 10. Did I do that already? And then I don't know why this isn't. See, I'm going to guess horizontal. Nice, I guessed right. And then this is also 10. It's just that. But the thing is, I really don't use parameters enough. And hold on, I don't think I ever. Wait, I think that's correct. But this. Oops. I think that this sketch is. Wait, what? Oh, I'm dumb. Okay, and then this is gonna be weird. Wait, why can't I click on this face? Oh, wait, what is that? What? What is this? Wait, what? Wait, I'm tripping out. What is this? Okay, I don't know, but wait, why am I freaking out? Why can't I select this circle? All right, I'm doing it again. I'm doing it. I don't know why that's so embarrassing. All right. No. It's not this. It's this, and this is 5. We said, and then is this okay? If I do this like that, then I do. So this is the horizontal, and this is going to be, what did we say, 10, and then these are equal, and this is 5 millimeters minus tap hole reduction. Okay, then we can now select this face and this face and remove. But for up to next isn't gonna work, but up to face works, and you select this. What? Up to face. Oh wait, I have to do them one at a time, huh? It's not gonna figure it out if I wait. No, I don't know. Wait, what if I try just one hole? Remove up to face, this face. Yeah, you have to do it at each time. It's kind of unfortunate, right? Oops. Remove. Okay, so then I tap those holes, and then I can put a set screw on them. And you know what? See, this is the thing: is the workflow of Onshape kind of encourages me to not want to just deal with putting in the assembly, but you kind of want to do, when you're working in Onshape, maybe you want to do the assembly as you go. So we're gonna say create part studio, or no, wait, no, sorry, I'm dumb. I wish there was more hotkeys. I wish I could just talk to this thing, honestly. I hate being a screen, bro. What is going on with my monitor? All right, so this is just gonna be called rename Z, and it's just gonna start with Z holder. Okay, and then we what? Okay, so we have this, and we're gonna fix this. Okay, now we want to okay, so since, all right, yeah, it's like how much do you include? But right now what we're gonna do is we're gonna see, now this is interesting. Parts that are the same but have a parameter changed, like in this it encourages where is our linear, we have the linear bearing rod. It's just rod. See, but we want rod parameterized. Like we want to I wonder if I can do that. Let's learn. Let's learn. Okay, so wait, configuration, configure. Okay, I've watched this before, but I forget what I do.
Configurations in Onshape give you the ability to manage variations of a product within a single document using design-driven choices. This streamlines the management, use, and selection of these components throughout your design process. For example, when inserting a configured flange into an assembly, you can select the correct variation of the product by selecting your design requirements.
See, yeah, okay, yeah. So it's basically part with arguments,
such as nominal size, flange style.
It's just a part with
arguments
arguments.
From a single complex list.
It's literally okay. It's literally. They've turned left 40 times and wonder what's next. Oh man. You should modify the gripper to hold a gun. I wanted to, dude, I've built a Nerf shooter. I really gotta finish. I really gotta make it. Dude, I gotta deal with that. I wanna just finish it. Alright, wait.
The choices. This also means that you do not have to be an expert in manipulating complex spreadsheets to create these configurations. This flange, for example, in a traditional design tool would require 570 separate rows to configure all of the variations available to the end user. Let's look at how Onshape streamlines the entire creation and selection process for this flange. When creating configured products in Onshape, you define the input criteria that the user will choose when selecting a product to use through a combination of lists, checkboxes, and variable inputs. Using the list option, you can define a selection of nominal pipe sizes for the flange. You do not need to create every variation of the flange at this point, just the 19 standard sizes for this list that the end user will select from. Once the selection list has been created, any feature or parameter in your design can be used to configure the product. This could be dimensional values, suppression states, formulas, and even input select.
Okay, all right, I missed how to do it. Bro, actually though, CAD programs are like... The thing is, Zoo doesn't have assemblies yet, bro. Like, I wonder how they're gonna do assemblies. Oh, because it's like... I can't wait to actually have an LLM just do so much of this. Like, it's so boring. Like, if we really think about it, this is so boring. I got this rod, and I just want to change its length. Okay, let's just speak in English to describe what we want. Okay, so the first thing I would say is add a rod parentheses 50, so 50 millimeter rod. And then I just add the mates. Okay, then I say M5. I say I have a part called M. I have a part called M, and it's a function called M, and it takes M. Well, I guess it'd be like head. I guess head geometry to make it fully. Yeah, bro. I love thinking about fully parametric bolts, but I would just say M diameter by pitch. Pitch makes the next sense. So it'd be nominal, major, diam, pitch, and len. And then I guess you could do like optional head type. So then I would say head type. Like this is gonna be the way that you write CAD is you just like say I want a bolt here with these three parameters, and it would be really cool is if it also, like when you do this part, just because those parameters are such a pure function, you could even identify that it's a part that you have in stock. Like this function in a real assembly, like if you took like a freaking SpaceX rocket and you just looked at every single CAD file for every part on the ship, and you look at these M5s, I mean, you'd want to know, like, okay, let's just count up how many M5s we need. And it's like, I don't know, maybe you can do that by exporting a spreadsheet or something like that, but it would be very cool that, like, it was all hooked up so that, like, when I call this function in some big zoo assembly, it would, like, I don't know, even, I like, it would just be, I don't know, maybe this idea is, it's less, like, important than I thought. But if I just call, like, M, and it, like, pulls up, like, my inventory. So it pulls up, because I just got some new, I don't know why I'm so, like, into the tracking of this stuff, but, like, I just got some new bolts. It's, like, all M3 bolts. So it would just be cool to know, like, as I'm adding to my... But how does it know how many that I actually used? It wouldn't know how many I have left. But it would be, I don't know, it'd be really cool if like I could track all of that. But that's a hard problem. That'd be tough. That'd be tough. Alright, so let's just get on track though.
Onshape, you define the input criteria that the user will choose when selecting a product to use.
What were the
process for this flange. When creating configured...
I think, wait, configurations, does rod... Okay, let's go to rod. Where's rod? Dude, I wish there was like I wish there was a command P. I wish this was like VS Code where I could just pull up a document. There's no hotkey to like pull up a document, right? There's like the search, But it's not like VS Code where it just pops up. Like I'm so sick of using this bottom thing. I don't know why I've lived with it for so long, but it's such a shit show. All right. There's got to be some document pull up. It's not like anyways. Okay, so we want to make a configuration though. Configure. Wait. Add property. I want to give it. I want to basically give it a variable. Choose sketch dimensions and future parameters to be driven by this. Oh shit. No, but it's not that. It's gonna be select sketches or features to configure, and it's gonna be this. Oh wow, that was easy. Is that it? Len. And Len's default is wait, but can I just give it configure features? No, hold on. Rod has no configured part properties. I don't know about that. Configuration variable. That's what I want. Oh, there you go. That's what I want. Yeah. Okay. It's all about configuration variable. Yeah, it's gonna be len. Its default is gonna be 300 because that's the, and then yeah, sure, that's fine. That's fine. Okay, great. So no features are configured. So we should. Okay, does it track? Wait, but hold on. I want to delete this whole thing. How do I delete it? What? How do I delete it? I don't know how to delete this thing. Extrude one depth. Oh, it's named. Oh, that's so sick. Okay, wait. So let's try to insert a rod into here. Wait, but this is not. No, wait. But we want Z holder. I hate the. Dude. Onshape. Honestly, CAD, bro. It's like. CAD gives me fucking anxiety. It's like. It's just so much worse than VS Code. Okay. So we want Z, this. And so now I want to insert rod. Oh, perfect. And we want this to be 30, or wait, hold on. So now we want to, you can't have variables. All right. Okay. All right. So we just say 50, right? I don't want to go too parametric with it. I just want to do it. All right, sick. That's pretty sweet, man. That's definitely how you want to do it. Okay. And then we just want to duplicate it, right? Has degrees of... Oh, and there's a little icon. We do want to make it a variable. Obviously, we want to make it a variable. Learning good design practices, but it's all bullshit, you know? Everyone's like, I know what I want, and I don't really care about it. But okay, but I'm sure that I can just, right? So this, to that. Dude, you know what's crazy? I don't know if, okay, here's a thought. There's probably a function that takes two parts, and the function is does intersect, and it returns a bool. And if does intersect, you know, whatever, part one, part two goes to bool. This would be great to call when it's trying to decide. Well, no, but the thing is that actually wouldn't be as useful as it would be vol intersects or something, and it would be like it takes two parts and it returns like an F64. I don't know though, because I don't really know the shape of the problem of like how to compute intersections properly. I don't really know how to do that. But the thing is, it would be really nice that when it's trying to decide, like, I'm about to make this mate. Well, I don't know. Let's look at the mate constructor. What's the default? If I'm just like out here in the nebulous and I go in and hover over this, it returns it pointing up. But then I go down here and it's pointing up. So the way it's doing something so like basic, but it would be great if it just like, a great heuristic would be like, pick the one that minimizes the intersection of the parts the most. Because if they have like basically, like for instance, if I flip this, the intersection between the two parts is 0. So it's like, all right. So whatever. That would be a really good feature. Dude, I swear, people gotta like go through my streams because there's a lot of good ideas in there. There's like a lot of good project ideas. Like people are always looking for fun projects, and it's like, but I do want CAD kernels to be better. But I also like, I just like, I don't know. I feel like a de-emphasis on coding projects, but it's also like, why though? I don't know. Building stuff in my hands is definitely fun. Because it's like a different way to like when you're just coding, you're not like, I don't know. Whatever I say, it's not as cool as actually building this thing. All right, so we got this. All right, now I want to do the next part, which is M5 bolts. And so I guess let me think about this. So, okay, insert standard content. Let's see what's in standard content. This is the problem. The problem is, well, okay, hold on. ISO, we want a bolt. We want to, we want a socket head screw. And then this needs to be a configuration variable. Length 16, terrible choice. Wait, but then where did it go? Oh, I have to click insert. Dude, okay, I guess I forgot about the auto assembly thing in Fusion. Fusion actually has I think Fusion has this nice thing where you just go bah bah and just do it. So let's escape this. What I want to know is if I select this face and this face, min distance is 4. So we want it to be like, we're gonna just make it the shortest one. So it's gonna be M3 by 6. But then it doesn't let me specify the pitch, which is so weird. I don't know. For me, the reason why it's weird is because technically, first off, I want it to be black. Carbon steel. What is it? I don't know. Let's see. What is it actually? This is the same thing. And it says it's black zinc plated, which I don't even know why they do that actually, but black, is it? And then in this case, it would be whatever. But I don't really care. It's not brass though. Oh wait, was there a? Did I see a color thing though? Oh fuck. Okay. Yeah. Just do stainless steel. All right, so let me just insert. What is this? Insert closest to selection. Oh wait, hold on. Let's undo that. Wait. No. So if we do insert closest to selection, I don't really know what that does. Oh my gosh, I'm so bad at that. I always have a bad habit of that. Anyways, I should be able to just repeat do it. Okay. I've never done that before, but is it the right part? Yeah, that's pretty much right. Wait, is it? Yeah, I have both. All right. Okay, so we finally did this thing. Now we got to do the rest of it. So the simplest part I can think of is the following. We just draw a rectangle. Oh wait, hold on, we can't do that. Oh, no, we're good. We're good. I'm chilling. So this is switch 2. Okay, let me sketch on here. We draw a rectangle from here. Oops. A G from here to here, and we can just make it. Hold on. But the I wonder if we can look at version 1. What if I can just open this in a browser. So how long was it from here to here? That's 15. I think we want to just make it. I just want to make this so much longer. I think that's the best plan. So we're gonna make this like from. I mean, it's like why constrain yourself in size before you even know what it looks like? I don't know, something like that. Wait, why is that not a parallel face? Tell me how far that is away, bro. What? I just want to know how big it is. What about that? Is that parallel? There we go. Parallel just 35. So we want like 35 plus 20. We want it to be like 50 long. So we want to go here and then Z, but we want Z holder. And then we want to go to the initial sketch. So it's just. So. Yeah, dude. I'm so bad at like true parametric design. Like, can't I just like? Isn't there like a way to just make this a dimension? Like, switch to dimension. There should be a tool where I can just like take this and like convert to, and just quickly move it over. Because it's like in code that would be so easy to move over, but there's all this like local state and there's all these weird pockets where you have to like delve into. It's like with a program, it's so nice because you can really abstract the problem out from its like core things. You can like just have this huge block of parameters and that's totally distinct from like the topology of the object or like some whatever. Anyway, so we wanted this to be like 35 plus 20, so 55. But the problem is it's centered, and I'm wondering, does that make things weird? I think that's okay. But why is this so long? No, this is definitely longer than it was before. Can we look at this sketch? Because this is definitely. How is this dimensioned? Wait, what? Is this centered? I don't understand what constraints there are on this thing. Delete that. I don't know what is that constraint? Why can't I understand what that is? What is that? Okay, hold on. I think this is just not, I think that was just, what was that blue? That was so weird. Okay, let's go figure out what it was in the other part. So now we want to just switch to, what part? Where's full? It's always just like go back here. There's always one level of indirection. You just go back to the main thing, and then you can click on what you're looking at. And what we want to know is this switch to. Wait, what? Oh, did I do that? Oh, that's funny. Yeah, man. Dude, AI can design so much better than humans. I swear, when AI gets good at CAD, it's going to be like, oh, it's going to be so nice. She'll be like, dude, you know what I want to build. And then I'll just be able to build the cool stuff. Then I won't actually have to like, yeah. All right, so we want to switch to, I mean, like, if you watch me, it's actually so embarrassing how slow, but I know exactly what I want. So it's this sketch, and what did I say here? I think it's to the middle or something weird. Okay, it's that. Yeah, what is, I don't even, oh my gosh. Oh, wait. Oh, wait, is that true? Wait, if I delete this, wait, what am I even doing, man? What a waste of time. Yeah. Okay. So what the heck is going on now? Standard content's a good solution to it, actually. I don't hate standard content. It's to have excellent taste. Okay. What are we even doing right now? See, that's the thing. Is like, bro, the operations you're doing are actually dumb as hell. It's like not that complicated, but it's so uninteractive, man. Like, oh my gosh, I really do want like a, oh my gosh, like a really interactive, like functional CAD app that was like so fast, bro. It's just like to really connect with the design. As if you could just beam your thoughts to the computer. I mean, that's the ultimate freaking Neuralink design, bro. Imagine if you could just like, I mean, is there a poly market for market when the thing is it's ill-defined what when does okay the claim is when will a top player in AI this is the claim predict when a top player will announce, I don't know, it's kind of like a second mover's proxy because it's like once someone breaks that barrier of like a recursive self-improvement of an AI, then surely everyone will hop onto it. I mean, it's like someone has to take the fall for the team of like innovating and then it getting regulated kind of fast, but then like all the big players still probably have it. I don't know. It would be it'll be a wild time when recursive self-improvement really takes off, man. Are people betting on when? All right, let's just polymarket AI recursive self-improvement. Another way to do it is when will the U.S. impose regulation on it? But that's like there's like a second order effect there. It is funny, dude. Polymarket is so sick. Anyway, it's like when do we know it happens? But the claim would be like when does this like because this may be in some sort of yeah, but it is kind of like a I don't know. But the other thing is like the way to solve problems is you just spawn 1,000 agents with different temperatures. Do you think like that would be a crazy thing? But it's like I haven't seen videos of an AI agent building building itself like from scratch. Why is that important? Whether or not it's from scratch. Because like, do we think? Because okay, here's the thing: is an AI can implement itself, but is it smart? I don't know, honestly. If even with like O3 and Arc AGI, do we really think that it can build a better version of itself that's like not just like slightly better but like significantly better? I guess there's enough humans to maybe guide it, but it's basically like how many years is it gonna take really before an AI really does recursive self improvement, and it starts to do. I mean, like, but the thing is, once that kicks off, the curve will be really high. But it'll change. Everything will be different. I feel like there's long tail of it, but this is like the ultimate like restructuring of the economy, man. I don't know, dude. That's crazy. Oh, jeez. Crazy, crazy. Okay. Uh, so yeah, that's the part. I mean, all right. So let's just what are we doing right now? Wait. Um, what is going on right now? Oh, this is V1. What is G holder? All right, but that's fine, right? It's fine. What's up? What's going on? I'm watching Curve stream right now. Let me mute it. the mic on?
I guess.
All right. Let's see. Check my gain. Okay. By the way, like if you pop into this show at like any moment, there's always something funny happening. It's like the best shit to have on in the background. You'll just watch it for 1 minute. I don't know what happened. Okay. So what I'm thinking is like from this face. Okay, wait. Let's just do the last part, which is just gonna be. I honestly don't even know why I need this part, but it looks weird without it. Take a look at this. Wait, what? Oh, there we go. Okay, so all I'm gonna do for this design, I'm gonna have. Oh, I guess the reason why I need the thing on the top is for the spring. So what I'm gonna do, and the thing is, I actually need to look at parts. This is the crazy thing about designing thing that's different though. It's like you have to take into account what parts are like. You could design anything, but people might not make that spring. So then you're gonna have to spend like way more to get that specific spring that's this length, this diameter, and whatever. But let's see. I have a spring set. Let me get the spring set really quickly. Because I don't think I have a 10mm spring.
What's wrong with him? I've never had lunch with him in 20 years when I have him looking at a wall. I say trick him the next time in terms of what time lunch is. No, I'm just going to show up a half hour earlier. Can we just have a moment alone? Don't start laughing. I'm fine as shit. Get the fuck out. You heard him. So good. You have your business. I'm trying to be casual, but it's really difficult. Remember the realtor from the art gallery? Yeah. Well, she had an open house. And let's just say it stayed open a little longer for me. Oh, yeah. Oh, yeah. An open house.
I can't find them. I don't know where I put those.
Cookies, took a nap. What?
They're probably right there. That's probably the springs. No, that's bolt. Whatever. Oh, I'm sorry. Okay. All right. It doesn't matter. Okay, let's just design the part. So now. Okay. So now it's gonna look like.
Is anyone else home?
No, my parents are out for like an hour and a half. Okay.
Why did you say it like that? Fucking creep.
I guess I just make a new part. This is the thing that's weird about Onshape, honestly. It's like. Anyways, I know what the part is. It's basically that mirrored. Like the most efficient way of describing the part would be like. Okay, I would say like it's quite literally this part. So keep these, whatever. Actually, that actually might be a hack. If I take this part, and that's probably the way to do it. So I'm gonna take this part, and then add a parts configuration. Well, the first thing that we want to do is we want to duplicate it. And this is going to be top of spring. Top of spring. And then we just have to delete a bunch of features. So we just take like, let's see, this feature, and this feature. So that. So it's basically this whole thing. This extrude is good, but this should just be deleted. Oh. Wait, what is that? Extrude 5. Why is that dependent on the rest of it? Oh, because you don't want to delete the sketch? Let's just delete the features then. This extrude, this extrude, this extrude. You can keep the sketches, why not? But not the first extrude, right? Just that, and then what is this one? It's that and this. Alright, and then I don't even care about the sketches, because it's fine. Just doing it the fastest way we know how. And then all we have to do is we need to change this sketch to be, like, not even that much, like 20. Right? I mean, that's all the part needs to be. It doesn't have to be any more complicated than that. So then we're just going to insert that into the assembly. And we need a rename. Oh, we did. Okay. So current document, and then it's going to be top of spring. Okay, and then we just need to map that to there, and then flip it, and then rotate it. Okay. Okay, so that's that. And then a spring needs to go here, right? But oh wait, but this actually needs to come further back, right? Because no, that's fine. And then is it better? It's actually, is it better if? No, I guess it has to be that way, right?
Yeah.
No, it does. Wait, why?
Just confirming.
Wait, because I guess it's fine. It's really it doesn't actually matter. I think it kind of looks like a chair almost, like a kid's chair.
Yeah, you just have to put the legs.
Yeah. Should I make a big chair? It'd be fun. It's just like that'd be fun. One of my friends from college, I exclusively send him videos of chairs on Instagram because he's like a design guy.
Send me pictures and videos of chairs.
Well, it's been like 4 posts over the past 5 years, so, but that's all I sent him.
I love a good chair.
I just sent him like, yeah.
So I can come back to social media with a good lineup of chairs.
Okay, I'll keep my eye out. All right, the next steps. Wait, can I scoot in a little bit? Can you put it behind me? Okay. Or wait, I actually have an idea.
Ooh, don't bother me.
Then you
I
can.
mean, as long as you're comfy.
Okay, what's next? We need to design a part.
He was having sex with the realtor. This is a funny show.
Yeah. Okay, so I guess what it's going to do is that there's going to be cylinders around this, or rather more like a block around this. What is this part going to look like? Is it going to look more like a bracket? Actually, making it look like a... No, you can't bracket it in. That's not going to work. But if it's like a... Let's say, what if we just took a rectangle like that, extruded it up,
What are you trying to do?
and then I guess we put the notch here. So the notch for the flipper to lift it up goes over there. So what I'm saying is like, okay, so like that, then this feature, and then we just need, okay, this part's actually really easy. And I was just like overcomplicating it, I think. So what we're gonna do is we're gonna do this, sketch on here, and then we're gonna draw a rectangle. Yeah, I think we have the room for it. It's basically if we have the room for it. Let's just make it 20. 20 is kind of steep, but I did make this longer, so I'll be able to fit the serve on. Okay, yeah, this is fine. So, it's a little bit asymmetrical, but, I think it's okay. All right, so it's going to be like this, and then we just want to extrude it maybe like, whatever, 20. What I'm worried about, oh wait, I did the wrong thing though, because you're supposed to, new part. It's going to be a separate part. And then the pillars are in the assembly file. And for some reason it doesn't like immediately do updates from like, because I think I know why it happens, but I think it's because when I selected Y rod holder, I selected the part but like in the part in the part studio, I think this is not a part studio, but it's a part. That's what I think it is. So if I go to Y holder right, then I have to specifically, oh, but this is the wrong, this is, oh no, it's Z holder, sorry. No, wait, it's Z holder? Yeah. Oh, but also I designed this wrong because that's not right. That's actually wrong because what we're going to have in there, well, it's okay. Let's put it in for now, but I'll show you why it's wrong. Also, we're going to need a very special type of spring for that. Because the problem is I want to do the math of like actually calculate out like, what strength of spring do I need? Okay, but there is a problem that I noticed from last time, which I'd like your input on. So basically, so the way that, I mean, it'd be better to demonstrate, but I don't want to go grab it. So imagine that there's a lip on here and the thing is lifting it up.
Okay, yeah.
So
like what? Wait.
Okay, there's the servo, and the servo lifts with an arm, right? It's like a flapper.
Okay.
And there's like a notch there, and the flapper's under the notch, and then it pushes it up, and then it goes down. So the problem, though, is mainly that at least on the last one, it could go too far and like flip over it, so then the thing would fall, and then it wouldn't be able to get back to its original state. So it's like down here, and the thing is here. It goes like whoop, and then it goes brrr, because this thing can't go down anymore. But it's like you kind of want this to always be able to return back to its home, because otherwise I have to keep disassembling it and like putting it back on it. But I don't know what that looks like. Like,
I mean, does it have to be like a lip that flips up, or are there other options?
it could look like anything. It's just it has to interface with the servo, and the servo has 180 degrees of rotation. So however we use the 180 degrees of rotation to lift this platform that eventually will have like a circle on it, like this thing taped to it.
On the back of it?
It could be anywhere. It could even be like what's a kind of a neat idea? I don't know if this would work, but if it was I know I have a pen somewhere. Shoot. Okay, if it, what am I trying to do? I'm trying to say, wait, okay. So if it's like, okay, if it's like this, and then there's the pillars, and then there's this part. Wait, that's not a good place to put that. This, and then there's this. If you you had the servo up here, you had this thing, and it hooked into it like this with some little beam or something, but it's actually hooked at the end of this thing. So it's actually like connected to there, but then somehow when this thing lifts up, this part, the
Like that
part,
little arm on the top
this
gonna
thing,
lift up?
yeah. So this part, this point is gonna lift up like this. Well, it's actually gonna go around like a circle like that, and then this is going to be able to rotate about this part. So this is kind of like two parts. It's like if you,
Yeah, I get it.
or I mean, it doesn't even have to look like that. It could literally just be like this with like a little rivet in it. But some part needs to like, because it's gonna, if it's forced to be straight up, it's gonna jam across this way. Yeah, just because the fact that it's following a circular path. But I kind of like this design. This is kind of, in some ways, a way more elegant design. Because it's so... The thing that's annoying, honestly, about servos in general is that you can't easily make your own horn because the tooth profile. I guess you can. Let me go get a servo. Well, actually, I have it right here. So this thing is threaded on the inside. So I guess no, but the thing is, the friction force between the bolt holding this in is not nearly as strong as it being surrounded by it. So you kind of have to like use a self-tapping screw where you connect a little thing. But that thing is going to be so weak. I did this like a while ago and it was like the worst because it's like this like imagine like yeah, I mean it's kind of like yeah, I guess it's like this. It's like this piece and it sits on the top of it. But it has these little holes, right? So then you add like just a little tab, a little basically just a flipper to make it longer. Because hold on, does this thing? I guess technically this part would ideally rotate around that too, right?
You saying that this little arm is gonna rotate?
Yeah. So this piece is gonna like go like this. It's gonna go. But I guess these both have to rotate, so it has to be like a. I don't know how to do that. You could design something where it's like there's like a rivet. It's like a rivet, a thing like this, and then there's just like a.
Is that the arm on the right of that one? Yeah, is that one gonna be longer?
Well, it's gonna be this.
No, go back.
Or I mean, well.
The arm on the right. This one.
Oh yeah.
It's that one on the right.
Yeah, it's
right?
the same. It's just.
Is that one gonna be longer?
Is this one gonna be longer?
Yeah, because if it's gonna rotate, that bottom one, it doesn't have a little arm. How's it supposed to rotate?
It's not going to rotate. It's going to the whole goal of this whole design is that this body is on the rails and it's going to just go up straight up. Yeah. Okay. Yeah.
But wait. So that entire piece is going to be moving.
Yeah.
So this entire thing is going to be pushing that up. Okay, that makes more sense. I was getting confused.
But I don't. This part is still kind of an unknown because, like, I mean, we could just hack it, but it's just not gonna like. What would it look like? Damn, I really need that pen. Well, I guess I can use this. So we have like a servo arm. Okay, and then there's a hole here. And then we just like slap a freaking thing like this on it. And then what I'm thinking is that I mean, it doesn't even have to be that long. I don't know why it has to. It could actually, we kind of want it as short as possible in some ways. So it's like this part, okay. And then this is hidden lines. This is like this gets self-tapped screw. So this gets it would be farther in than that because that's not really, and you would actually probably have two of them. We probably make two of them. You know, get two self-tapping or something to just make it real strong. And then, yeah, I like the proportions of that better. And then, this is going to have a hole. And then a piece, I mean, it's basically going to be a bolt. But I think it's going to be like okay, imagine a bolt. Let's do it like this. And it's going to go through there. But then there's like threads only at the end. And so you can because the thing is, you won't be able to put this whole thing through the hole. So you need to like make it in two parts. And then you just, but the thing is, this D is bigger than this D. So that then these threads, if you put a nut onto it, doesn't go past this point. So then you put a nut onto here. And then basically this part, I guess there's a third part, which is the loop, which is going to consist of one part of the arm. This feels so over-engineered. But like, I know, but the good thing is that it's
You're taking art class.
Yeah, yeah. Okay, what doesn't make sense? I think, but like, I'm pretty sure that this part will work. It's just kind of like, if it works, let's do it. I feel like let's send it because I'm much more excited about this design than the other one. I hated the flapper.
Just go for it.
Yeah.
If it doesn't work, you can come back to the drawing board.
Yeah, because the flapper, oh my gosh. Let's go to version 1 of full. This thing is such a butt to work with. This whole assembly, it's like you can't get in anywhere. It's all crammed. And it like...
Oh yeah, I remember you trying to unscrew the little bolts.
Yeah, it's like, oh, this whole design is just like frustrating, really.
I don't know, I still think if you just put little holes in the top of the
because of
brick
this?
part, yeah, you could easily access that. But I mean,
well, no,
what
but
else
that's
can you
like
access?
that's like that's relatively easy. I found a way around that. The way you do it is you
just get the short arm.
well you put your fingers around this thing and then you can get it started and then you can actually bend the plastic enough to just get the Allen key and just do it.
You shouldn't have to bend the plastic.
No, I know. Well, this whole thing is going
But
away.
I feel like even then you could just use the short arm of the Allen key and just slowly do it. You just have to keep picking.
I know,
it
but
keep
no,
it.
but you'll drive yourself insane. That's actually I should get like a ratchet.
Patience.
I should get a ratcheting one.
Yeah, you should. That'll be much easier. Oh my gosh.
Bro, how sick would this be?
Mr.
Oh my
Amazon.
gosh, this would be freaking. Wait, but is this Allen's? We probably have a ratchet actually. The thing is, that's big. You kind of want a really tiny ratchet. Anyways, wait, but I had a thought that I don't want to lose. The worst part about this was that okay, here's what happened. Here's a recap of yesterday. Is like so there's a bolt that goes on here and it goes through. And actually, what I started with was I put the bolt from under, and then the nut on top, and then there's a spring in the middle, so that the spring's length is 2 millimeters longer than the distance between here and here. So that means that by default, there's what's called preload on it. It has some initial force on it at a static point. It's just like a physics thing. It's like a very, very useful concept, though. It's like, okay, you have this design, and there's all these forces acting on the steady state, like the part is just sitting there at this position. And then, I don't know, then you can change those without changing the like overall position. Like if I made a stronger spring here, it wouldn't really affect the positions of everything else. But anyways, I think that's my definition of preload. I don't even know if that's engineering correct. But okay, so anyways, the worst part was like the servo horn fell off 2 times before I decided to put the screw on, which is like my bad, but also like then just getting everything out of this tiny little cramped space. But the worst part by far about this design, the reason why it just doesn't work, is that it jams constantly. Like you try to flip it up and it like doesn't settle down correctly. It like settles down at an angle and it does not. And I did not try the bigger bolt. No, you know what? I tried the bigger bolt in the CAD, but then it made me. I would have had to reprint everything, and I was like, I'm too lazy to reprint everything for the assembly just for this one thing. But I guess we're redesigning it now. So, but I just like this other design. I think this is a pretty design that will work. So this is okay. So this is like kind of at an angle. I have this bad habit of using 2 perspectives simultaneously. Like I start off with one perspective and then I want to just rotate it. But I'm so bad at the actual 3D things because if you had this thing and it would go like this.
No, I was joking.
No, I know, but I do. My cousin was talking about how important it is to like be good at hand. Like he's teaching a class in winter quarter. He's like going. Anyways, he's teaching the lab. But he talks about that he's teaching the lab for a class called hand drafting and CAD. So the first half of the class is all hand drawing.
That's actually nice. I feel like you would enjoy something like that.
Yeah, I know. I think I'd drive myself crazy, but it would actually be pretty cool.
No, I
think I would like it.
you
Yeah.
have decent art skills.
You think I do?
Yeah.
But like geometrically, or just like I'm an abstract artist.
No, I feel like I can understand your vision.
No Leonardo though. that guy was. I mean, he did work on this stuff for a long time, but I don't think I had the patience to just sit there and get it. I mean, Leonardo da Vinci, what a man, dude! Fucking awesome. Anyways, so then from this perspective, how would it look like? I guess it would look like it's like something like this. Oh god. And wrapped around it is like a. I don't know how to do this. How does it look like? It's gonna look like. I guess it's gonna look like this. And there's just it's just extruded by like slight amount. I don't know how to draw the extrusion lines, but it's like coming down this way. And it just goes through all of this. So actually, I guess what I'd have to do is I'd have to erase the line at this point. Does that make it better? Come on! What kind of erase tool is that?
Can you add another layer on top? And then can't you just erase the part that you don't want to be erased?
I don't know this software at all.
Oh, okay.
This thing is actually super. Wait, oh wait, there's a page. No, pages are not right. Wait, why can't I go back now? Where's my drawing?
Have you ever used the iPad?
A little bit, but I couldn't get the. I just always came back to paper and pen.
Yeah, I know. I like it.
Anyways, so I guess these lines. I don't know. There's kind of like a hole here, and so when you're installing this, you basically put it through. Wait, hold on. But how is this connected to? This is connected to the part that's connected to the servo horn. So, so there's this part, and then there's a second part, I guess. And this second part is, yeah, and the second part is the horn. It's like coming in here, and I guess it's the part connected to the servo horn. So let's see how many parts are there. There's going to be 1 part, 2 part, 3 part, 4 parts just for this assembly. It's kind of like a lot, but it'll work, and we're gonna go with it. But the question is, how do we get this bolt piece? Do I just 3D? Honestly, I just 3D print this. Like, why? If I know that a 3D printed design, it's just more CAD. It's like nice to use parts that you already own. But I think we could.
Let's just go to Home Depot.
Yeah, but they probably have something like that.
Ace Hardware.
What is this? See, like, what is this called? I know that this whole design must have some sort of name or be documented in some way, or the general class of what they do. Because what is the function of this? The whole function of this is to turn. Oh, the other part that would work is just like a big rack and pinion. Like the general class of this would be something that takes rotary motion and turns it into one-axis linear motion and doesn't jam. So it can go. Yeah, it's basically just rotational motion to linear motion, and the simplest one is rack and pinion.
What's it called?
So, there was like a video somewhere. Anyways, the like imagine there's a gear. And like the rack is like this rack looking thing, and then the pinion's a pinion. And then the side profile would be like you have this box, you have a pillar, you have this box, and then you have this box. And then I guess there's like imagine there's a gear like this, or maybe I would put it on that side. No, I'd put it on this side. But then I'd have to do like no. Because then connected to here, I would need this big thing. I would need some way to do this. And then there's teeth on here. And then when I guess the servo looks like this. And then there's the hub. Well, I guess you don't really need a big hub, but you'd fuck this design up. Wait, I got the because it's facing this way. So the servo is actually like so like here, and there's a thing here, and then I don't know. Anyways, why are we talking about this? This is just throwing out the kitchen sink. Let's just go back to this design. So I feel like I'm ready to hop into CAD. Yeah, it's just where are we at? I forgot where we're at. Okay, so how are we gonna do this? So, um, yeah, so the servo. Oh, but servo mounting is such a pain, though. Um, how are we gonna mount the servo? So what I did before is but I kind of hated these. First off, they're like really tiny parts, and I don't know. I just feel, and plus it's like I don't know. I just didn't like these. They were so. I kind of just. I feel like I always want to take a Dremel tool to this little fucking triangle because what I'd rather do is I'd rather have this be like I don't know. I don't know. I just feel like designing brackets for this thing is so lame. It's like how else can I? I just want to glue it. I honestly would love to just hot glue it, but I can't do that. I don't
Who
know.
says you can't?
I I wonder if it's strong enough or if it lasts. Like okay, every design decision has some trade offs. I just wonder what hot glue does.
You should do Gorilla Glue.
You think I should glue it? It makes it look so messy though, and the
What?
glue.
Wait. What about the glue?
Hmm.
Finish your sentence.
What?
Finish your sentence.
What? I don't remember what I was saying.
You said and the glue.
The glue's so messy.
Well, what part are you thinking about gluing? Which part?
Well, I would glue. I would glue. I think this will work. If I go to insert, it's gonna be other documents, MG995 assemblies, and I think it's this. I'll be implementing this, and let's see if we can do this. Mate this to here, and then rotate it. Wait, not flip, rotate. So it'd look like this. So then, I guess on here, actually we could build a little. I'm trying to think, because actually this is not so bad. I feel like there's a way that if we, because are these faces, they're not quite, but it's like I feel like there is a way to make a pretty low profile integrated bracket to hold this thing. I'm pretty.
Oh, wait, can't you just do two brackets on the side of it, like little L-shaped brackets that hold it down to the blue thingy?
Oh, so it like slides into. So wait, I'm having trouble. What exactly do you mean?
Just two L-shaped brackets on the sides of the black piece that go into the teal piece.
You mean that like go this way?
Yeah.
But how does that hold it from going up?
Hold it from going up.
Like, um, like
So
what?
did you want the brackets to be on this face?
Well, either yeah, base or like right just on top of this. So like it just has like a couple of tabs that are maybe 5 millimeters thick.
Oh, it's reinforcing the back.
Well,
Would you put another bracket on the back?
well, that's if you wanted to be really.
I feel like you have to.
So wait, hold on. Let's just get on the same page because I'm not positive we're talking about the same thing. So what I'm saying is I'm going to switch to this part, and then what we're going to do is we're going to wait. What the heck? Is this the right part? Oh yeah, it just has all this weird sketch geometry in it. What the heck? Okay, so the pole's going into there. So let me get situated again into Z. So this is okay, yeah. So it's on the side with the poles. So we're doing a sketching here, and I don't know if this is quite right, but I was just thinking like something like this, something like this, and then we're gonna just maybe just to add one constraint, dimension, whatever this point, to just go to the midpoint here, just so that it's like, because I think that's right. Anyways, then these are gonna be equal. And I think it's gonna be like, whatever. This needs to be like 40 or something. I don't know if that's correct. Wait, this didn't apply the constraint that I wanted, I think. Okay, wait, hold on. Let's delete that. This can now move. Or they are like... Oh, okay. What I'm trying to say... Oh, I can just do this. That's an easy way to do it. I don't know if that's quite right, but... And then we want to dimension this too. For some reason, my on-shape is being so weird right now. And it's like, that's supposed to be blue to tell me that the sketch isn't done, but it's like, I don't know. I don't know. Maybe it's the red light thing, but I don't... So this needs to be... Yeah, 10 is fine, but... Okay, they are equals. So I don't know how tall this needs to be. So let's figure that out by going to MG995. And then if this is sitting here, this face to this face. So 9. So we want to make it like 9 tall. And then the circle is going to be 3 tall. Almost done.
No.
Are you watching? No, you're sleepy.
No, I'm not watching.
It's okay.
I'll let you do your thing, then when you're ready, just show me.
Okay, yes, that's good. So this needs to be 9 tall.
I see the finished product.
Yeah, I understand. Okay, so wait, but hold on. We want to, I guess we want to sketch on here. We're going to do, but we want it to be in the midpoint of this line. So what we'll do is we'll do like this, and then coincident. And then we do, oh fuck. And this is going to be a Q. And this is going to be, how big does it need to be? It needs to be an M3 hole. So 3.4. And then I'm wondering actually if we can, actually in some ways it's advantageous. Well, no. Oh, this is so sick. So I'm going to just, well, I could do either. I could do either. So we remove, and it's going to be up to next. But what I'm thinking is that instead of making this an M3 hole, why don't we tap this hole? So first off, this to here needs to be 3. So let's get that dimension done. Is that true? Or is that this min distance? Because that felt like the min distance. So MG, this is the min distance. Yeah, it needs to be 5 up. Trying to trick me? Okay, and then instead of this, it's actually going to be 3 millimeters minus, I always do that, minus tap hole reduction. That's a tiny hole, man. But anyways, then I can just put the bolt in from the back. All right, so now what we want to do is we want to make a mirror plane. Mirror plane. Oh wait, that's, shoot. What you want to do is you want to select the 2 faces and then do plane. And then you get a plane. Then I want to do mirror, and that's a feature mirror. And I feature mirror just this extrude over this mirror plane. What? Oh, it's so annoying that it does that. I feel like that, oh, wait, I'm so stupid. It's like, why does it do that? Okay, anyways. So that's that, but we actually want to figure out what the dimension is from this face to this face. And we want to give it a little bit of clearance. So it's exactly 40, so let's give it like 1 mil of clearance maybe. So it's, what sketch is it? Is it this? What's not fully defined? This blue thing is driving me nuts. Oh, it's probably this. Yeah, so let's make this 4 millimeters. Okay, and then what did I need to change? This need to be 41. Yeah. See, what you would actually do, if you wanted to do this properly, is you would add all these, you'd make all these variables. But it's like so much work up front to make the variables that it's like, well, might as well just have terrible design taste. Okay. So we're good now. And we can actually do the, let's just, yeah, see, I got to get better at doing, we need to undo this thing, yeah. Better at doing the assembly while I do the parts. The problem is I don't context switch well, so then I just end up like getting overwhelmed. So we want to make this center. Wait, which side is it? Yeah, I want to be on that side. So there, like that. Wait, I got the wrong face of it. It's, yeah, it's this front face to this back face. Right? And then we want to actually offset it by, wait, I think oh. Wait, because it's in the center, but that's not, that's wrong. Okay, wait, let's make this, but then I'm pretty sure that this is, yeah. So what we actually want to know is, wait, but hold on. This face to this face is 40. So we want the things to start at, oh wait, hold on. I know what went wrong. This is so silly. So wait, we need to go here. We need to go back to, and edit the sketch where, because I know what I did wrong and I missed it. And I still don't know what is undefined. Like what is movable here? Something is, what? Okay. Yeah, it should be mirrored. So first off, this needs to be, okay, so, but you can't make a variable. It's such a pain in the ass. So this need to be, actually in Fusion, it's like way better because you can like take this as, you can click on it. Let's just do 41/2. I don't really care. So that should affect it a little bit. But this is not right. It's because it's in the center and the width is defining too much of it. So what we actually want is that it's going to be, wait, is that better? First off, the height is wrong. Why is the height wrong? Wait, did I? This here is 5, right? And then, so if this is, okay, if we're saying it's there, then this hole needs to be, okay, it needs to be 4 away from the wall. So we need to actually move it in by, we need to move it in. So then we go to this sketch 8. And instead of making this in the middle, which is dumb as hell, this needs to be, wait, is it 4 or 5? I think it's 5. Oh, wait, really? Wait, no, wait. The radius of this thing is 1.5. Oh, the radius is 2. That means the diameter is 4. Well, the diameter of that thing is 4? Okay. So, it needs to be 4 away. So it is moved in 1. It's actually 4 away. Alright, let's go back to the assembly here. Okay, it's still like kind of messed up. This is going to there. What? Oh, what? There, that looks way better. Now let's look at this side. I'm guessing this side will be offset slightly. Right. But that's fine because that's fine. I'm willing to accept that. Because basically what's going to happen is it's going to center and that hole is big enough that it'll be fine and we don't even need it to be that good. So we did it. We got it. Great. So that's that part. And so we're going to tap these. And I really want to set up my drill press. Okay. Now we need to design a part. And these parts are going to be really annoying to build, actually. Because, first off, we need to import the horn. Okay, so we're going to import that. Okay, did I ever do it? No, I probably didn't do it because it's in... I didn't download the CAD for the servo horn. So I need to go... Oops. That's not what I wanted to do. So I need to go to Chrome. I need to go grab CAD servo horn. Wait, let's just look up MG999, MG995 or whatever. Grab CAD. And, yeah, it's probably this thing. Dude, GrabCAD is so sick, though. It sucks that they make you sign in, but, like, whatever.
What is that?
Hold on, let me import. Wait, hold on. I almost made a grave mistake. Okay, import. I think I gotta extract it though. Here it is. Extract. What the hell is this? Extract all. Okay, so we want to import this solid part or this step file. Probably this. Okay. This step file. I don't know. Should I import the SolidWorks part? I don't know. Okay. I'm so much happier with this new design, guys. I think it's going to be a big, big thing. The cabling is going to be weird, I think, but I don't think it's going to be all that bad. Oh yeah, but I forgot to make this. I forgot to make this change. We actually need to change this. So what we need to do, we need to switch to this part. Oops. No, not edit in context. Switch to Z. I don't want to use that because I feel like that's evil. Okay, so wait. Oh, we have a problem then. Because, okay, hold on. This extrude was this. But what we actually need is to use these. We need a sketch. And now we need to make this. We need to figure out what. So if I go to full, and then I go and I hide the rod. Or wait, not if I hide the rod. If I take this bearing and hide the bearing, and I looked at the diameter here, it's 15.2. Oh, and so that'll have to be exposed too. So we're gonna go back to not this part, not this. We need to open up Z. But then we actually want to look at, oh, that part is in that part studio. Okay, so wait, but we want to go to, oh wait, not this part, Z holder. Okay, so I thought we were doing a sketch. I don't know where that went. In any case, this needs to be 15.2. But see how crazy that is that I'm not using a parameter? But it's like, I want to be lazy. Let me be lazy. Anyway, so we're clearly going to have to make some adjustments. But basically we need to do the same thing here. And then we're going to have to extrude that. Wait. No. Oh. Yeah, we're good. So we're going to have to use a longer bolt for this. So what we're actually going to do is we're going to go to this part. We're going to look at this sketch. Probably not that sketch. It's probably this sketch. Okay, so this can't be 4. We're going to do this to here, and it's going to be 15.2, or no, over 2 millimeters plus 4. Oh my gosh, the fact that it doesn't just implicitly convert to millimeters is the worst feature of this whole thing. Okay, great. So, but now we got to make this we got to make this initial extrusion. Where is it? Extrude. Is it this? Okay, it's this. So we just need to go to this sketch. Why am I so dumb? So this needs to be, here's the 20. So now we want, instead of doing this, we can make it equal spacing. So we delete this, and then we say this to this is 4. And now we have a part that will fit the linear bearing. But what we need to do is we need to add a feature. I can feel it. Wait, we have to, I made another mistake. So when we do, oh wait, but we can't adjust these rods, can we? That's okay. That's fine. It's kind of a thin wall, but that's not the end of the world, actually. We can manage that. Okay, so let's look at Z again, just to show you where I'm at. So, oh, and you know what we can do? This mate, let's look at the mates that are associated with this. Oh, wait. No, this is mated to something, but what is it? Why are these showing up? I don't want these showing up. I want to make this move. Oh, it's not, yeah, it's not anywhere. Good. I was so confused. So what we want to do is we want to take, and this is so weird to me. I don't know how slider works, but I want to let's hide this part. Oh, no. I want to take this, I want to hide it. Then I want to take, I guess, this and put it here. But I want to make it a slider thing. But I'm pretty sure that, well, I don't know. Oh, fuck, why am I so stupid? I'm making so many misplays right now.
Lock in.
No, I swear they have this guy, Too Tall Toby. This guy's sick. He does CAD tournaments. He's the only guy really doing CAD tournaments. Let's see if we got
our space
Fusion
clone.
versus SolidWorks.
Yeah. Yo, nice. Juiced, right? Little callback there.
That was crazy the first time. Who was that guy in the tournament this year who was doing SolidWorks super fast?
Yeah, it was QWERTY. We'll definitely talk about him a little bit.
Okay, let's focus on these guys.
Okay, so it looks like Imanta NP on the right from Nepal started out by creating the base with kind of the thickness of the base. I think I like that too. I like both these approaches. But Great Nate on the left, our number 1 seed. Really
Look at that
this
part.
already has his first solid feature. Just about to have his second solid feature. Now let's see what he does with his second solid feature. Looks like an extrusion in 2 directions. I think that makes sense.
Yeah, no, I'm not sure if he's restarting here or if he's
just
going to find
he's so close already.
You can do that. You do like a top view and then do extrude up to vertex and then click one of the vertices in your original sketch.
It was interesting to see Great Nate there. It looked like he had that original sleeve, and then was able to really quickly move from that into those 3 counter bores on the corner. So that was a pretty
fusion
exactly
wins.
he was able to do it. He had pre-cooked points in there, and he just pre-selected them while he was rotating the view. But he's already got that. It's like he's moving so fast. I'm not even seeing him make some of these features. Like, I didn't even see him create that fillet up top.
How did he make the outside triangle shape?
Well, we can maybe watch the replay in half speed, and then we can keep up with
I think
that.
what you probably did is you click the center point of those arcs. So if you know that those counterboards are going to be, what's the word, co-radial with the, not co-radial, concentric with those outer parts, you can just tap that inside part. And I think on some softwares, you can just click the outer part of the circle, and it'll automatically snap to the
Smart.
center one.
That's smart. He's able to do that quick. Now, you were talking about, whether or not this model has any tricky features. I think Great Nate is now running into the one feature that maybe is going to be a little bit tricky. We'll see how he handles it. Looks like he's got some type of a hole library that he's able to use to get that hole on the back there. But you can see that hole is not just a straight through hole. It's got,
Oh,
it's got
he's
some
cheating. He's got a whole
Yeah, I noticed that after I made
library.
my comment, but
Dude, this
just
guy's
finding
gonna
some of
win.
the
No
bases in
doubt.
there and where to start and end might be a little
100%.
tricky.
Yeah. I see someone in the chat is asking, actually, I'm going to go back and remind me to go back and read that comment after you're done. I don't want to get distracted from the action. So there we see Great Nate was able to get in there. Looks like maybe he's going to try and do this with some kind of a chamfer. Is that what he's using there? Very interesting.
Home strategy, got it.
Yeah. Yeah.
Wait,
home
what is
strategy.
that
We'll see
part
if the
look
tolerance
like?
allows it.
Yeah, we can see the way that feature. If for those of you that are watching this on the DVR, you can go back. You can just kind of roll back. You can look at the print. Or this is another good spot where you want to take a screen capture. When that print first shows up, you want to grab a screen capture too, and that way you'll be able to watch. I see Victor K in the chat says, "Got it now." That's a cool way to flex if you're watching and you're modeling it yourself and you want to flex a little bit. You can say, "Hey, I got it," but you definitely do not want to post the answer.
Yeah. I was just doing, I guess what we've called the layout approach in the past. So I never really did this until I started competing for speed. And, generally it's maybe not the best practice when you're doing real engineering parts. It works, it's not bad, but generally you kind of want to go feature by feature. So in 5 years, your coworker can open up the part and actually know what the heck is going on with it. But in SpeedCAD, it's really nice to just put a lot of features all on the same plane. I even like to do revolves and bosses on the same sketch, and then you can just use a contour selection and just click through and make multiple features from one sketch.
Well, it's funny you say that because I actually went through a very similar evolution where when I first started hosting these tournaments, I was really not that into the whole multiple features in one sketch. But then as I saw more and more users doing it, I not only adopted it, but I really learned a lot from watching them about those strategies. And it's like you said, even adding in revolved features and boss features in the same sketch, the advantage is that then you can relate those features to one another very easily in that same sketch. And so that part of it has really made it easier to create complicated designs where multiple features are all related to one another.
Yeah, it's kind of like a top-down approach. It's really easy to go back and edit your geometry if it's all in one sketch, but it kind of locks you into that geometry. If you go
And
back
you know
and
what's
say,
cool is
I
that the
want,
questions
this
they
layer-based
ask is
triangle
like,
instead, there's
what
probably
is
a
the
breakdown
mass
feature
of
that
the
you built
part,
into that.
assuming
But
some
if the
density.
core
So
geometry
you
is all
don't just like
pretty solid,
design
you
the
know
part.
how
The
to
way that
change,
they
it really
check
locks
is
you
if you
into
get the
something like that. So it's
right
really
mass.
depends on the part. That's
Yeah.
what happens with me.
Yeah, Victor K is commenting on this as well. He says, I tend to do the opposite. Layout sketches help me get a good design in 10 between features, and speed modeling, I do simple features quickly. So that's interesting. Okay, we got Great Nate coming into the chat with an answer, and his answer is 2,533 grams, and that is correct.
Yeah,
So
good job,
yeah,
Nate.
congratulations to
Wow.
Great Nate.
Wow, what a sicko. Wait, should we just look at the print? Where's the print? We don't get the print? There it is. Oh, that's an interesting geometry. This hole here, these. Wait, what is that? Oh, that's a diameter, I guess, yeah. Thank you. And then this is 50 degrees. And then what is the depth of that hole? I guess it's okay, I guess it's whatever it is. What is that inner radius though? 52. Oh, but they call it out as a yeah, this is more like an engineering drawing because it actually specifies how to make it. Because like most of the drawings that you see, like all this, like this all tells you how to make it. And it's crazy because like they don't even like in 80 they'll like the parts that you make, they'll tell you like, okay, these are this is the order in which you need to make the features, but you should go into it and like try to ignore those and think, okay, how would I make it? Because at the end, you do make a few parts where it's like a more traditional, like all you get is a drawing, and then you as the machinist have to like figure out the operations to get it to the right spot, and it's like way harder. You're like, what am I doing? All right, so we're time to lock in. Yes.
All
right.
Play block blast.
Okay.
While you lock in.
Thank you. Slider mate. Let's see. Let's play it. Okay, perfect. Yeah. So I don't need the limits, but we do want that. Oh wait, but I did it wrong. No, I didn't. I just hit a part. Okay. All right. So we are kind of almost there. We just need to add. I don't know how we want to do. We need to add basically 2 more features to finish off this part. And let's go and name this. I wish I could name it from here. It's in Z holder. No, wait, yeah, it is. This is going to be the rename pen holder. So I'm thinking just another. What I kind of want though is like a lip over this thing where I can put 2 screws will make it more annoying to. Well, I also need a better hand screw. Like I really don't like I think I would prefer to use a bigger screw. And then and so basically like this sits over the top of this thing, but and then we kind of need to know how high this is going to be because the other one has a much lower profile, so it's closer to the ground, which you actually want. You kind of want it to be lower too. Like if the screw, like imagine the pen is like super long and it's down here. It's gonna have a much bigger lever on which to affect force from a distance. With a big enough lever, you can move the world. Who said that? With a big enough lever, I can move the world. Archimedes. It's Archimedes, obviously. Give me a lever long enough and a fulcrum on which to place it, and I shall move the world. That's rad, man. Think about how big of a lever you need. If you stand on a planet and it just lifts up. Archimedes, man. I know nothing about the guy. Except for the screw. Archimedes screw. And I think he came up with a way to determine the volume of something is by submerging it in a liquid. But I don't know if that's true. I think so. Or at least, well, I can ask ChatGPT, but let me not get distracted. Okay, so wait, what we need to do now is we need to fix this part. See, that's the problem is I should have made these freaking parameters. But whatever. Let's just keep being naughty. Naughty. So switch to top of spring. And then we're going to we need to make it that, yeah, okay, wait. So there is actually a parameter in here that is worth knowing. So if we go to Z holder and then we look at the sketch, let's hide the pen holder, and we look at this sketch and it's this, and we get this 11 point whatever, we're going to go to our variable studio and say that Z holder Z holder wall to dist basic, or not dist, center to cent. Or we should actually say far wall, which is like kind of ambiguous, but whatever. We're only going to use it in a few places. But it's okay. We get this 11.6 millimeters. So we should be able to now go back into a few sketches and use that. So this first one is going to be this sketch. And we're going to now use this Z holder, whatever. And then we got that. And then I think the next one, let's unhide this. I think that this is just because we used the other thing. So this doesn't actually have a dimension associated with it. So now we just have to go to top of spring. And we have to fix the... Wait, why did this open up the straight up wrong thing? Okay. So how are we going to do this? I guess this distance. So we're going to... is it this sketch? Whoa, what the heck? Is that for real? Wait, let's just redo it. I just don't even want to use those. So this sketch, I don't know what is this sketch? Oh, really? So we have this extrude. Okay, wait. So we want to let's just fix this sketch. All right, I'm just going to delete it. And then we're going to roll back to there. Or you know what? No. Here, we're going to take this sketch. We're just delete all this random stuff. Just clean it up. I don't even know what this is. What is that? 8.2. I don't even know what that is. So delete this. Do we have a horizontal constraint on there? Yeah, so it's 10. Oh, and this, wait. This is 8 point. Wait, is it 8.2 or 10.2? Where's rod? I wish I could jump to rod hella quickly. There's rod. Rod's outer is 8, right? Yeah, so we're good. Okay, so 8.2, and then the distance, not from there, but to there. This is going to be... Oh, yeah, Bug. All right. Oh yeah. So wait, we need to go back even further. So this is gonna be Z whatever. Wait. What just happened? Wait. Did I do it? So yeah. So that comes in there. Okay. So that's fine. The only issue is I do want it to look nice. So we're gonna just go back to this initial extrude, and it's gonna be, I think it's, is it 40? We really should have made a parameter for this. I think it's, wait, it's not that. It's gonna be this, which is 23.2. Let's just keep it like that is. Where is it? 20, okay, perfect. And then if I take the distance from here to here, its min distance is 7.5. So plus 4, that's 11. Okay, I feel like that's right. Okay, we're getting close. Let's go to Z and see how it's looking. Okay, so this is all aligned. This has room for the linear bearings, which actually we need to insert those. So let's get those linear bearings. Linear bearing. Okay, and let's add another one. Okay, and then I think I can just do it from here without having to move everything. This could be like this to that, and it's fastened. And then we're going to do this one to this one, which is great. So now we have pretty much most of the thing here. We just need to actually do the 2 features that we've been talking about this whole time. And then, ooh, wait, hold on. The height, oh, geez. Oh, geez, Louise. Oh, my gosh, I thought your head was further up. I'm sorry. So, what is the height of this or this linear bearing? Is it going to tell me? No, wait. If I click on a cylindrical face, it's got to tell me something like the length of it. Come on, man. What the hell? It treats it like a circle. So wait, let's just hide the pen holder. Let me just click on this face. Oh, come on, man. And then hide this face. Wait, that's the wrong one. Hide. Oh, what? Whatever. So the height of this and this, 24. See, that's how much I didn't want to switch documents in this stupid crummy app. So that's 24. So that means that when we actually did this extrusion, we need to... And we have holes there, right? Wait, we don't even have holes on there yet. We need to add the set screw holes. Okay, so we actually have more features. So in Z holder, do we want them on the inside? I guess we want them on the inside so that it looks more beautiful. So we're going to put this... That's so sweet of you, but I don't agree. I think pretty objectively most of it is garbage.
Yeah, you're right.
I mean, I appreciate the compliment, but can we just look at like this part, for instance? What the fuck is this? Everyone else looks so good, and this is so clown shit. And this one's fine. This is fine. It just doesn't have a lot of strength. It's like also pretty just like...
No, it's like dog shit.
I kind of agree. I mean, the other ones, they go way further out, and they go further in too, so they just have more surface. I don't know. They look stronger. Okay, wait, but let's hop back into some freaking CAD shit. So let's just do this feature. Okay, the first thing we need to do is go to this extrusion, which is literally like, what is it? Is it this? No, I don't think it's that. Oops. Wait, what is this face? Oh, it's literally just that. So this needs to be linear bearing height, but whatever. See, that's the thing is like, oh yeah, man. I have to put all these secret numbers into this program, and then it just stores as local state, and it's like such a annoying thing. Okay, then we want to sketch on here, and we gotta go circle, circle, equal the distance down. I don't know, what do we have a regular number for that? This is 4.6 because it's threaded. To here, what is it? That's min distance. Wait, what is the radius of this? This is okay. This is gonna be like. Wait, can I just do center dist? Isn't there a center dist thing? Center dist. Oh yeah, so it's 5 down. Okay, so let's just make it 5 down. Okay, and then the diameter of this is going to be 3 millimeters minus tap hole reduction. Yeah. Wait, but I still have to tap it. So it's like, whatever. I might put threaded inserts in there. We're going to try threaded inserts with minus 0.4, but I feel like that might be like too much. So we want to do a remove up to face and then click. Oh, yeah, you can't do this. That's such a silly thing. It's a common enough thing, right? Like, it's like, yeah, I want to make 2 holes. I don't know. I guess I could just give it a distance, but I feel like up to face is a way better way to do it. So wait, why is this sketch not? Oh yeah, because it's not at all defined. So this is 10. And this is a mirrored feature, but I guess I have to like be ridiculous about it. Okay. So now I gotta select on this feature, or face, remove up to face, this. It's like just to do simple things, you have to click so many times. All right, cool. And are we gonna be able to, I might do threaded inserts there, we'll see. All right, so we're getting there. Now we have, let's see, let's unhide all of this stuff. Wait, what's going on? Is it just this part? Okay, so clearly that's gonna be not enough travel. So we're going to have to, I think these are both, oops. Wait, how do I edit the configuration? Change configuration. So we want to make this actually like, how much taller do we want to make it? The travel of the, I guess we need to calculate the maximum travel of the servo. But it's going to be so sick. I feel like I haven't been this locked into CAD in a while. Oh yeah, it's in here. Yeah, we got apple. Oh yeah. I don't know. But ever since that they haven't machined it.
No. It gives me a race to change everything.
No. But this doesn't
You have what they could never achieve.
It's from all these cookies. It's from all these cookies you're giving me. Okay, where were we? Oh yeah, we need to make this taller, but what we actually need to do is we need to calculate the travel. So let's get a new drawing here. So we have like these tabs. Then we have the servo. And the servo has this thing here. And then it has this horn. Okay. And this horn. I hate that this erase feature is so stupid. Why the hell is it per line? Okay. Whatever. So we have this flipper, and what we want to calculate is actually when it's from down here. Say when it's from down here. Wow, that's terrible. Okay. Then there's something connected to that. And I wonder how we're going to make that part. Because I guess we could do a blind hole and tap it. Or we could do a blind hole and put a threaded insert in it for all I care. But then that's going to be just a post with an end on it. Okay. Okay. So now we need to design this part. So this part needs to be like, it's going to be like this. And I guess it's going to go behind it. I mean, imagine it goes behind it. But then this part, this face here, is going to be at the same plane as the servo. So it's kind of like an inset part. And then this has, what's on this? This is just the tab that connects to the servo. I don't know. Yeah, so that's fine. So we can figure out what size hole to make this. And then this is like that. Okay. And then now we just need this. And this could just be, I guess we need to 3D print that bolt or something. Because the problem that I had yesterday that was so crazy was when the nut was on the top of the flipper thing, every time it pushed it up, the bolt would go up, and then the nut would slide down ever so slightly. So then after 100 uses, it's just totally locked in. It's like, oh man, I didn't think about that at all. Okay, so okay, so we have control over defining this distance. Okay, so, but the thing is that distance we want to be defined maybe by the distance between here and this thing. So this thing is like this, and it's got this weird hand tightened bolt type thing. And I guess I could use, I don't know how that would work. That's kind of sus. That's why you kind of want, oh, but you know what you do? Actually, here's the solution. You use a bolt. You could use a big bolt so you could hand tighten it. You put a threaded insert, but then you just use a bolt that's longer than the depth of the blind hole. So then it's stuck in place, but it has that gap. Okay, I like that plan a lot, actually. So we need to go get the threaded inserts and look at them. because ideally I use like a big. Well, I guess I could tap them. Why not make a big tapped hole? And then no parts use. I think actually, if I really thought about it, I think tapped holes are more unhealthy than threaded inserts. If you have a fan going, which I really need to get a fan. Thing is, it takes up so much space. I gotta get a fan. All right, so that's what I'm gonna do. Big threaded insert. Okay. So how big does it go? I think it goes to M5. M6. Oh, wow. That's great. With a depth of 8. Wait. The depth of 8. Okay, so it's going to be a 7.6 size hole. Okay, so this is going to be 7.6. And, okay, so that's that. Then we put a big hex bolt on it so you can use your hands. It doesn't slip or whatever. And we'll just use a relatively long one. And we can play around with the length of it. And and then the depth. How do you do the depth call out again? GDT callouts. There's a good website actually for GD&T callouts.
My butt hurts.
Why?
You got any games on your phone?
I actually don't have any games on my phone.
No Block Blast?
I actually have no games on my phone. The last time I had a game on my phone was like senior year of high school.
What? No Block Blast?
I've never played Block Blast. Wait, what's the depth? Whole depth. Wait, why did the TV turn off? Did I turn that off?
Yeah, I think you did.
I did.
Yeah, I'm an iPad baby. I need to see something.
Let's put back on Curve. I love Curve. Curve is so good.
I don't know, my butt really does hurt though.
Did you go to the gym?
No.
Oh. Why does your butt hurt?
I don't know, my legs hurt. I think it's from yesterday. Was it yesterday with JJ?
Oh, the hike?
Yeah, it was such a steep hill, and I had to carry his little fat body.
Oh, you had to carry him? Well,
Yeah,
it's
he
got to
got
be
tired.
that then. Dang. Well, yeah, I mean, yeah.
He's pushing 50 pounds.
Dang, that's a tough to climb up a steep hill carrying a 50-pound baby.
He said, "My feet hurt."
No.
I had to.
Yeah, you can't deny
But he
that.
wanted to go to the top, so we had to go to the top.
Oh, yeah. That's the fun thing about kids, right? Yeah.
He wanted to see the view.
That's nice.
And maybe you stretch me out.
Oh, depth is like this. Depth is like line with a thing on it. So it goes like, where's my TL draw? So then the this thing is like, and the depth of this is 8. Okay, cool. And then we can just put it in the middle, and then we want to put it in the middle here too. So what's the easiest way? Is you do a line from the side.
Pass me my glasses, please.
Yeah. So, okay. So we need to make that longer, but we're not there yet. So what we need to do is we need to go to this part, switch to, then we need to do a sketch on here. And yeah, I never know about one sketch per or not. Because we have this sketch, which I guess is still ill-defined. How is that even possible? Oh, what? Dang. See, that's where I should have mirrored it. Ugh, wasted. Anyways, that could have been bad. So sketch on here. Do a circle. Oh, cool. Do we have that midpoint? I don't even trust that midpoint. Let's just draw Yeah, it's a circle in the middle of this thing. So the way that I do this, which is kind of weird, is I make a construction like this. Okay. This, this is a good...
If you can ask the elderly man to move out of the aisle seat.
No, but it gets better. I always get his writing is so good. Okay, so then on here, this dimension is going to be 7.6, and then its depth is going to be 8, and it's going to be a threaded insert. Oops, wrong way. Wait, why didn't it do the thing? Wait, what? That's correct. Selected tools and targets don't intersect? What the flick are you talking? Oh. Oh, wait, but now the merge scope is messed up. Great. There we go. Okay. So now we have this. And I guess we could just put threads, but I don't know. What's the way to indicate that this is... Do I just put helix? And you just do that just so that people can see it? I guess that makes sense. Oh, max 1? What the hell? Okay, so helix means there's either a threaded insert or a Okay. Okay, what does Z look like? So this is kind of jank. Because we need this, what?
Like a ball and shiny his head.
Yeah.
Can you get that haircut for me?
Yeah, I'll get that haircut. Okay, so we need to know, did I ever import that thing? This. Oh, we need to insert that into Z. I forgot about that. This is going to be gear. It's just called gear. Okay. Oh, wait, but we want to change that actually. This mate is not a mate, it's revolute. Perfect. Alright, so now we need to design that part. So I kind of want to like... I kind of want to like take that part and duplicate it. And then like build off of it.
I need to call me honey.
You want me to call you honey?
Sugar plum.
Okay. Lock back in. How annoying is this going to be to install? I think that'll be okay. Alright, so let's figure out. Oh my god. This part is so big. I wish those linear bearings were smaller, but so let's imagine it was the minimum distance. So the minimum distance, see, that's kind of the issue, is we want actually to make this feature a little bit different so that, okay, I guess what we want to know. Okay, the width of this is what? This is like 80, right? Okay, so we have 80. And then what we want is that this offset, so the distance, let's hide the gear. We got to get the circle part of that. That's the kind of the bad part about this part. See, that's a length. That one, that's a radius. So that radius gives us that center point. Now we want to select this edge, and we want to get the details of the distance, and see how the y is about 50. So what we want to do, so then the servo horn is 49.798. So then that means that minus 40, or let's just say 80 over 2, that's going to be 9.798. Okay, so it's like almost 10 off center. So what we want to do is, I think this is going to be actually easy as hell. And this will make my life so much easier. So we're going to go here and we're going to switch to this. Switch to top of spring. And we're going to look at this sketch where I do all this, build this notch. Oops. This sketch. No. This sketch. Okay, what is... It's got to be this, right? No? What is ill-defined here? I don't even know. I hate that I can't see the blue. Oh, it's that. What even is that? Who knows what that is? Oh, wait, we need that. No, this is a center line. We want to move this thing. So we want this to be... I'm pretty sure this distance, we want it to be 41 over 2 minus 10. Ooh, that's so close. Come on, man. Let's get rid of the equal constraint here. No, but then it's an asymmetrical part. How cringe is that? Well, these don't have to be 10. Let's make them 9. Oh, and then mirror. You can't mirror it. You just need to add this feature to it again. Let's just quickly do it. Oops. What just happened? Is this the wrong one? Hey, what is it? Who? Richard Lewis? Okay, then this extrude also. It's like, but then there's this weird little notch here. Okay. Alright, wait, but is the. Okay, but that means. Oh, that's perfect. Wait, but why does it still not look. Alright, wait, let's take this circle. And this circle. $47, but that's not. See, the problem with this is we need to. When we did this slider mate, I want to select limits, but I don't want to. If I select the limit, can I? Ugh, see, that's the thing, man. But how do I know how much this is? Okay, so that's why I'm going to actually change this from a slider to... I'm actually just going to delete this. Okay, there we go. So now it's stuck there. So now we actually know what the actual amount is. Okay, we're close. Holy cow. Wait, but we actually, why don't we just put the this thing on? See how far off that thing is, though? Where's my water? Okay. So we're almost there, but now we need to... Okay, so now what we want to know is the... Okay, so the next step now is to determine how much travel I have. So there's some pivot point around this point which is going to link these two things. This point to some point here, beyond this thing. Okay. So let's just design the part. That's the only way. So we're gonna switch to this, and we're just going to basically we're gonna inset this. Okay, so we're gonna draw a sketch on here. This is on the back. I'm gonna draw. It's not an add, it's new. But then we actually want to go further than that, right? Wait, hold on. Oh wait, but we actually no wait, hold on. Let me go like this. I gotta pee. I forgot, would you guys have cauliflower and what else?
Just made pasta,
Oh,
but
yeah,
I didn't really
pasta.
eat any because my tummy was hurting and I had salad.
Oh, my parents
So I said I'm sorry. I mixed in a little bit of